you can give a range like this, and you can whatever number you give inside it, it will just print everything until there. So let me just run this particular part, and if I run it, it gives different numbers inside it. And okay, fine, it's not giving everything in here. So let me just take it to my Jupyter notebook, and here let me paste it. So one more thing is there. Let's say if you are in this particular cell, right? There are keyboard shortcuts. So these are different keyboard shortcuts which you can change, and which you can which are basically helpful for you to run different commands and basically add different functionalities. So I can add different cells here. Then if I have to delete them, then I can select them and press D twice, and it will delete everything. So yeah, we are looking at range, and this is x equal to range 6. And if I just click on Control Shift minus, it will just split the cell at that particular point. Okay, so this is very useful in terms of let's say if you want to break your cells, right, at a particular point. So it's very useful. This is a very useful shortcut for that. You can just press Control Shift minus. So this is what I'm talking about. This one. Okay, cool. So this is x equal to range 6. Let me just print it. It prints like this, and this is the type of it. It gives a class like this. And if I just want to print the values from for this, then I'll just print it like this. It will just give me values from starting from 0 till 5. Okay, and it will not be including whatever the ending value is there. All right, so this is range. Then we have dictionary. So dictionary is like a key value pair. Okay, so this is your key, this is your particular value, and then this is your set. So if you look at both of them, they look similar. They start with curly brackets, but there is something called index in Python, and an index is nothing but how Python looks at different positions. Okay, so these are different positions like 0, 1, 2. So index starts with 0, and index just means that how basically position of a particular element is there in your data structure is. Okay, or let's say for a string in your data type, what is the position of a particular point. So this is 0, 1, 2, 3, like this. Okay, now why it starts with 0 is that in most of the languages, indexes start with 0, and they just represent the memory location, and this memory location is n elements away from the starting element. Okay, so the first element will be 0 elements away from the starting. This is the reason that indexing starts with 0. Okay, so this is also called as, this process is also called as indexing. And let's say if I'm using indexes or labels to assess parts of a data structure, then that process is called as slicing. Okay, so yeah, coming back to it, dictionary and set, they both have curly brackets to start with, and this is key, this is its value. And these are different. Let's say for set, it is similar to list and tuple, but it is unordered, it is unindexed. The concept of index doesn't work on a set. And normal set operations, right, which you would have read in mathematics, like intersection, union, all of that, they all work in set. Okay, then in your dictionary, let's say you have this key and you have these values. So your values can be duplicate also. Okay, it doesn't have to be unique, but your keys have to be exactly unique, these keys. Okay, the name cannot repeat twice, thrice, like that. So yeah, this is the concept of dictionaries and sets. So these are your basic data types and data structures in Python. Then you have Boolean. So Boolean is your true and false, and Python uses Boolean interchangeably with 1 and 0 also. Okay. So yeah, there are some
Hello,
exercises.
Prafu.
Yeah,
Hello.
yeah, I'm
Uh,
able to hear
but
you.
in previous, you show that booleans are different.
Booleans are different. Different as in?
Different means you show that is correct, incorrect.
For connect.
Correct, correct.
Correct. No, no. So this I was just printing it. This was I was just using it in a print statement. So if
Okay.
yeah. So let's say if I put 4 equal to 5.
Huh.
Sorry, not this. Like this. Okay. So it is giving a value of such as true. Or let's say if I just want to understand booleans better, then okay. So let's say for this particular example only, okay, if I have to just print true and false, then I wouldn't have to put it inside this thing. I can just put them directly like this. Okay, I mean here I should put false, and here I can directly put true. So these are inbuilt in Python. Okay, and let's say if I just give an example like this. This is my x, and if I'm just typing my x, it is just a list, right? It is starting with square brackets, ending with square brackets. It's just a list. And if I do x dot sum, okay, it's not giving anything, but let's say if I'm taking the first index of x, and if I'm taking the second index of x, then it is giving me a value of 1. Okay, so this has a value of 1, this has a value of 0, so it is giving me a value of 1. Let's say if I am adding the third element as well, so it should give ideally a value of 2. The sum is 2, so this is my sum is 2.
Okay, means Python inbuilt. These are inbuilt function.
Correct, these are inbuilt functions in Python, true and false. These are basically booleans. Okay,
Okay.
and Python considers them as 0 1 sorry 0 and 1. So 0 for false and 1 for true.
Okay, and in if else, if the condition is a if condition is a true, then it will take as a one.
Yeah, I mean it will print as true or false, but ideally, I mean you can sum them up. So let's say if you have a data frame, right, and if you are trying to look at the missing values, so what happens is if you'll just print out is null in a data frame or in an Excel file, it will give you true false like that. If you'll just use dot sum in front of it, it will give you how many missing values are there and how many missing values are not there, something like that.
Okay, okay,
Yeah, yeah,
okay. Thank you.
yeah. So this is your data types and data structures and your indexes also. Now these are your variables, like this x is my variable, this particular here, this particular x is my variable, and let's say if I'm looking at it here, then this y is my variable. So y, my variable is nothing but a memory location. It is used to store values, and you can just equate it with anything, any data type or data structure, and you can directly use it. Okay, now other than this, you can, yeah, you can look at some operations with list here. You can probably use negative indexing to print the last item. Okay, so your positive indexing is 0 1 2. Okay, and your negative indexing is this last item is -1 -2 -3. So if you're counting backwards, it is negative indexing. If you're going from here, it will start from 0. So let me just put something here like and I just put a string as well here. Okay, now this is a list I have created, and let me just so this is coming out to be like this. There are certain kind of list operations, so I can take out its length. So there are 6 elements inside it, and I can just add one item to it. So I can, let's say I want to append this particular thing. Okay, now if I'll print it, it'll add just one more element to it. Now if I want to do indexing, right, then it will start with 0. If I want everything from 0 till end, I'll print it like this, so it will give me everything. If I want only the first element, I'll just put 1. And if you put anything after this colon in this particular range, then it just gives the first value. Okay, so it's just giving me 1. Now if I give 2, then it will give me 1 and 2, basically the first 2 values. So yeah, these are some kind of list operations that you can do. If I want to do negative indexing, then I'll just print -1. It'll just give me the last value. Okay. So yeah, these are certain kind of operations. We can do negative indexing to print the last item here. So it will be just -1 and we'll submit it. Then you have certain operations around tuples. You can do if else. So print yes if A is equal to B, otherwise print no. Okay, so if A is equal to B, I'll just put a colon here, print yes. Else, again I'll put a colon here and I should print no. So if A is equal to B, okay, so sorry, here, right, for A equal to being equal to B, you have to give 2 equals. So now if I'll submit it, it will be like this. So the same thing if I'm wanting to do here, right, X and Y is there. So if I'll just do X equal to Y, it will give something like false. Why is it doing so? Because here I have defined some other X and that is not equal to this Y. So I'll just have to rerun this particular part. I'll rerun this part as well. I'll just check it here, X plus Y is equal to 6. Now if I run it, it will give me true. Okay. Okay. Let's see if I want to put X is not equal to Y. Then I'll just put a exclamation and equal to, and then if I'll print it, it'll give me false because X is equal to Y. Or let me just check if this works. Yeah, this one is not working here. It works in some languages. So yeah, this is how you can do it. This is how you can just write a if else loop. You can give certain conditions around it. This is again talking about indentation. So you can just click it till here, and if you'll press it enter, it'll work out. Then you have loops, and loops are nothing but there are 2 types of loops, and loops are just used for iterating over a set of cells. Okay, so let me show you an example for this particular value of X. For I in X, now this I, you can keep it anything. So for I in X, what do I want to do is I want to print I. Okay, or I want to basically, let's say I want to do this print I plus 1. Okay, now if I run it, it will run for this, it will run for this as well, but then it will say can only concatenate a string, not into string. Why is it doing it? Because this I, right, this particular me, this is in a string format and this is numeric format, so it won't add these two. It won't be able to add these two. So what I can do is I can just put str, okay, and it was able to print till 4 of these. So this X, let me just put it for rest of the indexes, 0, 1, 2, 3. So starting 4th index. Okay, so if I print it, it is printing something like me1 ty1. Okay, so I just converted it into this one into a string so that it can concatenate this string and this string together. Okay, so this is for loop, and we have this while loop as well. Now what while loop does is print I as long as I is less than 6. So I'll just write while here, and I'll just put this here. So first it has defined I equal to 1. It has just given 1 to a variable I. While I is less than 6, it will keep on printing. As soon as I becomes equal to 6, it won't print anything. Okay. So let's say in our case only, what we can do is for X, I in X, we can write one more loop. While I is less than 3, print I plus 1. Okay. So see, it has become a kind of a never ending loop. Why has it become like that? Because it is just keep on printing like this. So if you face something like this, what you have to do is you have to do kind of kernel interrupt. Okay. Now what I'll do, I'll just create a just give a value like this, I equal to 1, and while I is less than 3, print I plus 1. So again it is creating something like this. Okay, so if you'll try to see something what we have done here, it is printing it and then it is giving I plus equal to 1. So as soon as it becomes equal to it, right, it should ideally stop. So let me just do print I instead of doing that. So for I equal to 1, while I is less than 3, print I. Okay, not sure. So I ran this and then I'm running while I is less than 6, while I is less than 3. Ideally it should stop at this particular one. I'm
No,
not.
first of all, you have to give I is equal to something now. Then it will store there. And
Okay, correct. So basically this part you're talking about. Yeah, so I did this and yeah, okay. So yeah, I basically have to store it unless it goes back to this while loop again, and otherwise it will just keep on running. Thanks for that. So let's try to do it on our list. Yeah, go on.
hello, Praful.
Yeah,
I have one doubt
yeah.
regarding to loops. Is there any special cases that how to decide which loop is better for what? Means how can we decide
So
we have to use a for loop or while loop?
so for loop is simple, that whenever you have a set of values and you just want to iterate certain operation over this set of values only. Let's say if I have this particular list and
Hmm.
for I in X, let's say if I want to iterate it only over the first 4 set of values, right? So I'll just give 0 till 4 and then I'll just put it like this, print I. So I'll just print these 4 values. But let's say if I want my if I want a specific condition to be satisfied, like here I want the condition to be satisfied as while it has to be less than this particular value. Okay, then only it should print. So I'll just,
Okay.
yeah, I'll just give for loop, and inside that I can give a while loop. While I is less than 3, then only it should print.
Okay.
So
Thank
while
you.
do we use when we have to use a certain specific condition? Okay.
Okay.
Okay, I used it in a different way. Basically, it should first add it and then it should make it equal. So 1, 2, and then again it will come till here and it will just print it out. Okay. So yeah, this is your while loop. Then you have your functions. So there are two types of functions. One is your normally how you define a function, and then there is your lambda function. Okay. So lambda function is basically your anonymous function. It is you can basically define it as it is. You don't have to use def or anything like that. Let's say this is your functions, and for defining your functions, you have to use def, then the name of the function, and then whatever set of statements you wanted to run. So that is your function. Now you can give any set of values inside it, and then you just have to call using your function name. And let's say if you're given certain arguments inside it, then you will have to call. So let's take some example like this. Okay, like this one. So here it has defined a function, my function. Then here it is given an argument, then it is a for loop, and then it is just printing it. So whatever you will give inside it, right? If it is giving it a list like this, fruits, it has these three values. So for X in food, in this particular value, whatever argument I have given. So this is just the name that I have given. Okay, this name I can replace it with anything, my variable name or my data type or data structure name. So it'll just keep on printing it. Then you can use return also, and return is used to basically stop a particular function at that particular point. So wherever you are using return, your function will not run any of the item afterwards. Okay, so let's say if I'm just printing a function here, let me just name it q, and let me just give it x argument. Then this function, whenever I call it, it should print there is q. Simple. Okay. Now if I'll just call it, this will just tell me the function name. If I'll just try to end it with brackets. So it'll just print this. There is a q. Now I can also give certain value inside it. Let's say I, and then I can use that value. So I can just print I. It also has to print I. Okay. So now if I again run this one, it will throw some error. It will say that it is missing one required positional argument, this value of I. Now this value of I can give anything. I can give it some string also. So it will print this, then it will print this, and it will just print this I. Okay. Now let's say if I am doing this return, or not even here, let me just do it here. This is what I wanted to return. I plus 1. Okay. So I ran this function, and inside the function, let me give the value of 8. So if I run it, it is giving there is, and then it is printing this 8 plus 1 9, and that's it. After this it won't print anything. If I want to comment this particular part, I'll use control /. Okay, control plus forward slash. So if I just run this part, if I just comment this part, and then if I run this, it will run return this is commented a q, and this will print 8. So this is how you can define a function.
So basically, return function is used for only stop the code.
Yeah, kind of wherever you want to return something, right? Let's say if I want to save this results to a particular value. Okay, so let's say if I want to if I wanted to return this, there is 9. Okay, now if I want to, if I can equal it to this value, and if I print x, whatever return is there, right, it will get assigned to this x. So this x has been got assigned this 9. Are you getting it? So this printed this particular part, and this return value, whatever was there, it got assigned to whatever variable that I gave.
But you didn't call function, na?
I call, right, this is my function q.
Okay.
Yeah. So I just assigned it to something. So like this, you can create something like this, and you can assign the final value to a data frame or a list or anything like that. And in the return, you can give anything, whatever. Let's say if you created
So
a
you call a function
Mhm.
by putting in some variable called x.
Okay.
So what is a return function?
So return function, what it does is whatever value is here, okay, whatever value is here, it will just get assigned to this particular variable. So it is same as x equal to 9. This is also assigning the value to this. Or if I run this function, I'm just taking a function q, and I have given this value. And if I'm running it, then also x get assigned a value this. How is it doing? Here I am putting 8, and then I'm returning I plus 1. So 8 plus 1, 9. So like that.
Okay. Now I get.
Okay. Okay. So this is your basic return function. Then you have a lambda function, and this lambda function, what here it is doing is it is adding 10 to the whatever number is passed. So let's try to understand this. So here we are not using any kind of def or anything. Here we are just using lambda function. And what is a lambda function? Lambda function is nothing but a anonymous function. And you use lambda, then you use whatever your arguments is there, like a, b, c, d, like that, and whatever expression or whatever condition you wanted to satisfy. Okay. So it, whatever argument you are giving it here and whatever condition you are giving it here, it is an anonymous function in the sense that let's say here, right here I have given a set of conditions here, but I also given a name to the function here. And this function I can now repeatedly use along in my code. But let's say that if you just want to use it once, okay, you don't want to unnecessarily define some different function names or something like that, specifically in case of data frames or something. You have a data frame, and if you just want to perform a particular set of operation on a particular column, then you'll just use lambda, and after that you will give whatever condition you want on that particular column. Let's say if you want to square that column, whatever numeric column is there you have, so you'll just use this and you'll just power it up, and it will give this value. Now if I run this, and inside this x, if I give 3, so okay, I'll basically have to print it. Okay, I'm not sure why it's not working. Ideally it should give a value of this thing, like how it is giving in here, right? It is summing it up. So like that, it should give a value like that. If we try something, what
No,
is
for power you have to use double what that power thing, no? Or something. it is not single.
Okay, okay, okay. You're basically saying that we have to use functions ordering other groups activities can't be created because it is like a nameless virtual function. Yeah, it is a nameless virtual function. Correct. You are saying like double quotes like this. No, I don't think it will take it. But yeah, if we just try to understand it with this example, we are just taking some whatever argument. We can give this argument as I also. This argument and then whatever expression we want it, like I plus 10 or I minus 10. Now if I'll just try to print it, and if I give it a value of like say 455, it'll just subtract 10 from it and return us this value. Okay.